Which is the four potential. The definition of four potential. The electromagnetic field is characterized by four vector AI called the four potential. Called as four potential, which describe the properties of field AI. Which describe the properties of field AI. AI, which is I equal to 1, 2, 3, 4, therefore A1, A2, A3, A4. Here you put I equal to 1, 2, 3, 4, therefore we obtain A1, A2, A3, A4. But A4 equal to 5, that's the scalar potential. And A1, A2, A3 equal to A vector, that is the vector potential, this phi is the scalar potential and this A is the vector potential. Therefore, we write the four vector AI equal to A phi, where A is the board, A is nothing but A1, A2, A3. Again this is written as A means AX, AY, AZ in component phi, and AI is given by minus A into phi, minus A phi. Again this vector is expressed as component form like this. Then we say the electromagnetic field tensor. The electromagnetic field tensor. That is given by Fij. We define Fij as Fij equal to del AI by del Xj minus del Aj by del Xi. It is second order tensor and it is antisymmetric. It is anti-symmetric. Therefore, by definition of anti-symmetric, we get Fij equal to minus Fji that is if I find F14, then we get minus of F41. If we interchange the suffixes I, j, ji, F14 can be written as minus F of 41 like this. The tensor Fij has 6 independent components. As F10 F23, F31, F14, F24 and F34. Now from F12 we can obtain F21, from F23 we can obtain F32 with this condition antisymmetry Fij equal to minus Fji. The values are equal but only minus sign is there. These components can be expressed in terms of electric and magnetic field strengths. The field Fij is called, the tensor Fij is called electronic field tensor. So vector Fij is called electromagnetic field tensor or the Maxwell tensor. Now we can find this Fij, all the components of this Fij in the matrix form. We obtain first, we derive first, and we write in matrix form all the 16 components, including the antisymmetrics and the zero components. Now from this formula 1 we obtain F23, I equal to 2 and J equal to 3. From equation 1 we have F23, I equal to 2 and J equal to 3. Del I2, del A2 by del X3 minus del A3 by del X2, and put the value of this in the previous article. We have seen the values of this del A2 by del X3. I have written here AI equal to AX, AY, AZ, I, and AI equal to minus AX, minus AY, minus AZ, I, and XI equal to x1, x2, x3, x4, x1 equal to x, y, z and ct. x1, x2, x3 and x4. x1 equal to x, x2 equal to y, x3 equal to z and x4 equal to ct. Del A2 means this is A1, A2, A3, A4. Now from this we have A1, A2, A3 and A4. Therefore A2 equal to we have minus A1. Therefore del of minus A1 divided by del x3. X3 means z minus del A3. A3 that is A minus AZ divided by del x2. x2 means y. Therefore this becomes plus del AZ by del y minus del AZ del AY by del z. Now we can remember hx. My previous article we have seen this hx, hy, z. This is F23, but we know that F23 equal minus F32 equal to we get minus of hx. Then next we obtain F31. Put I equal to 3, j equal to 1 in equation 1. Therefore del A3 by del x 1 minus del A1 by del x3 equal to del A3 means minus az divided by del x1 means del x minus del A1 means ax minus divided by del x3 means del z. Now the second one minus minus plus del x by del z minus del az by del x. Now you can remember like this, here is xz and zx. Del x by del z, here del az by z, that is variable here x and z, and z and x reverse. Like this here also z by yz. Now this is nothing but hy. Now f31 equal to hy, therefore f of 13 equal to 100 minus of hy. Now then f12 put I equal to 1, j equal to now a1 means minus ax, x2 means y, a2 means minus ay, x1 means x. Therefore this minus minus plus del ay by del x minus del x by del y. Okay, nothing but hz. But f12 equal minus f21. Therefore S21 will get minus of Hz because this tensor is antisymmetric. Then next value F40, put I equal to 1, J equal to 4 in this equation 1. Then del A1 means minus A, del X4 means del CT, del A4 means del A4 means 5, X1 means del X, therefore over here minus 1 by C del X by del T minus del phi by del X. The value of this is Ex. This is F40, therefore F41 will get minus X. Because of antisymmetry. You can obtain F24 as del A2 by del X4 minus del A4 by del X2. A2 means minus A1, X4 means CT, A4 means del X2, 1 minus 1 by C del AY by del T minus del phi by del 1, which is nothing but EY. Therefore F42 equal to minus EY because of antisymmetry. And you can find F34, put I equal to 3 and J equal to 4, you will get the EZ. And F43 equal to minus of EZ. Write all the components in matrix form. In matrix form, Fij is expressed as Fij equal to zero Hz minus H1 Ex minus Hz 0 Hx Ey H1 minus Hx 0 Ez and minus Ex minus E1 minus Ez 0. And all the diagonal elements are 0, and because of antisymmetry property, here is Hz, here minus Hz, minus H1 plus H1, Ex minus Ex, minus Hx, E1 minus E1. Now this way of Fij, this is F11, F12, F13, F14. In the second row, we have F21, F22, F23, F24. In the third row, we have F31, F32, F33, F34. In the fourth row, F41, F42, F43, F44, F44 is 0. So this is the required matrix of the electromagnetic field tensor Fij.